Anyway, our next speaker is Anton, and he is going to tell you a bunch of things that you wish you had known when you were developing really cool experiences with HTML5. So here he goes.
Hello, my name is Anton, and I work for Plain Concepts. During these last few months, we've been working with Microsoft, building some cool web experiences, trying to promote HTML5. And today I would like to talk about two of those, and especially the problems that we had and how we solved them. So hopefully you will learn something today, and it will save you the time that we didn't have at that moment. Whoops. The first one I want to talk to you about is about the training center for the project Prometheus. This website was built with Ignition Interactive and Plain Concepts and was part of the campaign for the movie. Let me show you. Have a problem with the resolution? Yeah, probably. I can actually open it in Chrome if you want. It will run. So actually this website, we knew from the beginning that it was going to be a very fun one because it had a bunch of videos, a bunch of audio that we all know that they work nicely across all the browsers and there is no problem with the codecs. And there was also something interesting, and is that half of the games were 3D. And we know that IE supports WebGL, right? No, it doesn't support, so it was going to be a really, really pain. Well, I had the last game at the end, which is I'm going to skip this part. So this is the last game, which is 3D, and you can see it running now. So the problem that we had, we wanted to focus more on the 3D part because it was the most painful one that we're going to have with IE. And I'm going to explain the approach that we take to solve this issue and how we make it work across all the browsers. So the first thing that we tried to do was use SVG, mainly for two reasons. The first one was that designers were going to be able to give us the assets directly. And the second one was that we didn't have to take care of the hit testing because it was already supported by the browser. So we did a bunch of tests, actually not that much, it was only like 2 hours. And we had like a cube spinning, and we started to freak out because it was super slow. I mean, it was like 10 frames per second in all the browsers, and we know that this was never going to happen, and we only have like 7 weeks to do that. I mean, we changed to another approach. So the second one that we have was to try to reuse those SVG files that we had from the designers and try to reuse them from Canvas, creating kind of a pseudo 2D environment, 2D 2.5 environment, and trying to pre-calculate all the movement of the pieces. And that worked nice for a cube, but we had a bunch of other different figures, and well, there was no way that we were going to be able to pre-calculate all the movement of all these pieces. So finally, there was this guy in the company, which is a math nerd and a 3D freak, that said, hey, we still have like 6.5 weeks. Why don't we do our own 3D engine? I said, like, well, it's our last shot, and if we don't make to do it, we all be fired. So yes, let's do it. And well, that's what we did. We did a 3D engine, and actually, that wasn't that complicated because this guy is super smart, and well, he is already a C# developer and he loves games. And with a JavaScript developer, he did it like in 2-3 weeks. The most difficult part was to make all the tweaks to make this run smoothly in all the browsers, in IE, Firefox, Chrome, and everything. And that's the part that I would like to talk to you about. All the small tweaks that we did to make it run smooth. So the first thing that you know when you have to perform is that strings are always costly, in no matter what language, and JavaScript is not an exception. So the first thing that you need to take into account is that if you are creating strings and you have some values that all the time repeated, like RGB or parentheses or commas or things like that, you should make a constant value and just access that value. The second part is that how you create your string matters. If you go to Stack Overflow or GSPerf, there are a bunch of tests and a bunch of people that advise for one way or another. I would advise you to try all those tests in your environment, in the context of your page, because we had some different results. Some people like the method of array.join and then, well, you know, the strings that you have in the array, some other the plus or plus equals and things like that. In our case, what worked best across all the browsers in average was just using the plus sign. Actually, array.join was the slowest one across all the modern browsers. I think that array.join works well for IE6, IE7, and IE8. If that's your case, you're programming or targeting those browsers, I'm deeply sorry for you. The second thing that we tweaked was the accessing some of the properties that we had. Well, we had a 3D engine, so we obviously had our own vector3 property object with X, Y, and Z properties. And that we saw that accessing and updating all those values was really, really slow. And, well, that's weird, because in all the GSPerf tests that we saw, it should be the same speed accessing an array value and a property. Actually, sometimes it's even slower. But in our case, replacing the vector3 object for an array of 3 numbers, it worked great. So again, all the tests that you see in your... It's better now? No? So all the tests that you see in GSPerf and Stack Overflow, take it with caution. Don't assume anything. Then we're getting huge improvements, but it was still not like 60 frames per second. And, well, we needed that 60 frames per second or we are going to be fired. So we opened the IE developer tools, we opened the profiler, and we saw that MathFloor was really slow. I don't know if you've ever had this problem, but I actually thought that the built-in functions in the browsers are expected to be faster, but no, that's not the case. So in this case, we replaced all the MathFloor calls for a bitewise OR operation, and the speed improvement was huge. So if you're having these kind of problems, think about the wise OR operation. And, well, after this change, everything was running perfectly. We had Firefox working, we had Chrome working. And the only thing remaining was I was still a bit slower. And, well, Microsoft being the one paying this project was a bit of a problem for us. So we remember back on the old days when the compilers weren't as smart as now, where they didn't do the inline. So some developers actually copy and pasted a function that was being called several times directly into the code. So we identified one function that was being called like 200,000 times every couple seconds, and we inlined it into the function. And that made the deal. I mean, we finally got to see our wives and actually stop eating pizza, and we were happy. Microsoft was happy. Ignition Interactive was happy because their experience was working. We were happy, but Fox wasn't happy. What happened? Well, the website didn't work in iPad. Someone forgot to tell us that it should work in the iPad. And what was the problem? Well, the problem is that Safari for iPad can only handle one media tag. And this website had like tons and tons of videos and tons of audio playing at the same time. So, well, we were kind of screwed. We invested like 3-4 more days trying to redo all the flow, especially for the iPad, and removing all the sounds that were playing at the same time. So, if there is something that you have to remember from this experience, is that don't try to do 3D if you're not using WebGL, because it's just not worth it, unless they pay you a lot. The second part is that all the tests that you see about performance, you should take it with caution, and you should always do it in the context of your web experience. Even if you think that that test that you saw in GSPerf is exactly what you need, that might not be the case. And the third one is that if a client tells you that he wants a lot of video and audio, please ask him that very second if he wants it to run on the iPad and set the expectations right. The second project I want to talk to you about is our Thief of Thieves. This project was developed by BAM, Fastest Forward, and Plain Concepts, and is based on the comic book. I don't know if you've ever read it, but it's really cool, so go and buy it. I'm going to talk especially about the heist, which is the part where Plain Concepts was more deeply involved, which is actually a 2D game. When first Microsoft came to us about this project, we were pretty excited because we've been using internally CascadiaJS to do some tests, and well, finally we were going to be paid to create a game in JavaScript. But the problem was that they wanted this game to be in SVG. And it was like, really? Do we need to do it in SVG? It's like, yes, do you want to be paid? And it was like, okay, let's do it. Well, we invested like 3-4 days checking all the game engines that we saw out there and trying to see if there was someone that could place nicely with SVGs and that could adapt to this experience. And we didn't find any. So what we do? We created our own game engine that works with SVG. Well, if you see the game, you're a thief. You are in the roof of a building. You have to infiltrate, take care of the cameras and the guards, and steal something. So, I can play a bit. Everything that you see here is SVG. So what I want to talk to you about now is about all the performance tweaks that we have to do in order to make this game run smoothly in SVG. So the first thing that if a client tells you that wants this is just run away. That's my first tip. The second one is that well, when we started this project, we were nervous because, as I told you before, we just finished Prometheus and we knew that SVG was going to give us some trouble. But the moment that we actually had something into the screen that actually moved, two things happened. Well, actually one. All the team sent resumes to other companies. And the second is that those unlucky guys like me that didn't got a job in another company had to deal with this. And, well, I still wanted to be paid at the end, so I'm going to explain you all the things that we did to save our jobs. The first thing is that we had this massive SVG file that the designers sent us. It's exactly as the one that you saw. And it was really nice. Well, it's really nice. But, I mean, that was really a pain to manipulate via JavaScript. I mean, it was super slow, and it was just not practical enough to modify it. So the first thing that we did was to slice all these SVG files into smaller ones. We had the camera on one side, then we had the guards, the player, we have the background, walls, and things like that. And actually that gave us a bit of performance, but it was mainly for the JavaScript developers to take advantage of that. The second part that we figured out is that as soon as you add an SVG to an HTML, it starts being part of the DOM tree. And the more complex the SVG file is, the more complex the DOM tree is going to get. And we had, I mean, those SVG files are thousands of lines, and the DOM tree was being super complex. And actually, we didn't need to operate or to communicate with those SVG files because, I mean, it was the background, so the user was not going to be doing anything with it, or the walls and things like that. So we needed a way to add those SVG files to the website without the browser adding those extra properties and methods and things like that. So then we remember that, well, SVGs are another type of image, and we can actually put it as the source of an image tag. And we put it, and we were happy because it worked. I mean, we moved from about 15 frames per second to about 30 frames per second, and that was a huge relief. The second part, the next problem that we had was with the cameras. The cameras, well, if you've seen it, they run really smooth. The problem was that at that moment it was like, It was really choppy. And have you ever tried to animate SVGs? No? Usually, if you Google animate SVG or something like that, it will advise you to use SMIL, which is like the way to animate SVGs. But, well, there is one funny fact is that I10 doesn't support SMIL. So we were animating by hand with a set attribute property in every request animation frame. And the set attribute method is really costly. And we were actually, well, we targeted like 60 frames per second. We had 3 cameras, and then we need to add the guards, and then we need to add the player and everything. So it was just making all of this run super slow. So then we remember what's the other way to animate things is use a CSS3 animation, and then you will get the hardware accelerated thing. So again, the canvas stopped being an SVG. The cameras stopped being an SVG camera to be the image of the source of an image tag. And then we add the CSS3, and then we got the 60 frames per second, which is kind of nice. So we're, again, happy. We got like 40, 45 frames per second. And then we start moving our character. And, well, we had the same problem. It was like, come on, why can't we have the usual way? You have your sprite with all the positions of the character, and then you just move it, like you do always with Canvas. Well, the thing is that we had like 10, 15 different SVG images, and we were changing them all the time. And as we saw just before, changing an SVG is really, really costly. And, well, the thing is that actually we can do exactly the same approach. We can have a very huge SVG file with all the positions and use it as the background of a div, which is kind of nice. And, well, that made the trick, and actually the demo started working much, much better. Actually, we hit the 60 frames per second. The only remaining problem was doing the collision detection with the camera, because, well, we had the CSS3 animations, but before we knew exactly where the camera was pointing, but now, well, with the CSS3 animations, we are kind of screwed. So the workaround that we used was to guess where the cameras are pointing. So we know where the animation starts, we know when it ends, and then we said, hey, you should be somewhere like here, for example. And, well, it actually works. I know it's not ideal, but it's the only thing that we can do. So if you have to remember something about this project is SVGs can be also images, and they can be hardware accelerated if you know how to use them. That's the most important thing. And, well, that's the conclusion of these 2 projects. I've added some others from other projects. I would say that the most important is about the performance. Don't believe what all the people tell you. Always use them in your context. Video and audio is always going to cause you a trouble, because you have like WebM, you have OGG, you have H.264, then you have to compress them to get the same quality across all the browsers, and actually getting the smaller size. So it's always going to give you trouble. And then we have the problems with iOS that only plays like one video or one audio at a time. And, well, the extra tip for this will be hire a full-time tester if you are doing this kind of projects. It's extremely important to have a tester whose only goal in this life is to break the work that you do. So please hire a tester and tell all your developers, your colleagues, to be mean to this person, because then it will be extra motivated and the results will be even better. And, well, that's everything. So if you want to talk more about other problems that we had in other projects, or keep digging more about SVG and performance, just talk to me. Thank you very much.